Good morning, guys.
Morning, Joe.
Hey, Joe.
Hi. It's actually not my morning, but it's your morning because you're in Australia and I'm in America. So that's how that works. Cool. Good to see you guys. Yeah, I think last time I saw, I'm blessed with having two Davids today. So uh, uh, I guess, David Tan, do you want to start off by introducing yourself?
Yeah, happy to. Yeah, thanks for having us, Joe.
Yeah,
So, yeah, I'm David, to disambiguate from Dave Colls. Yeah, so I'm an engineering manager at Zero, previously at ThoughtWorks. So, yeah, I'm basically spent my career building software and ML products in, and lucky to have had the chance to build ML systems in accounting, in real estate and retail, and a bit of LLM engineering in the past 2 years or so. Yeah, and maybe I'll throw it to you, Dave.
Thanks, David. So I'm Dave Colls. I worked with David Tan over many years when I built the ThoughtWorks Australia data and AI practice. And as part of that, we delivered a number of ML projects for our clients. I'm currently working with Next Data on the intersection of data mesh, machine learning, and AI.
very
And
cool.
caught up with Joe when he was last in Melbourne for Data Eng Bites, and we had a little chat in the corner, and I thought it would be a great opportunity to continue that on the podcast today.
It's awesome. Yeah, big fan of Next and what what's happening over there right now. So, but you all also did something interesting. You guys, you wrote a book, which is pretty awesome. Tell me about that book.
Do you want to go, Dave? I can show the book.
That's
Yeah,
the book.
great. I can talk to
Let's
it.
go.
So,
Hold it back up again. What's the
Oh, yeah.
what are the animals or birds or whatever you
Yeah,
put on there?
it's a southern tern, apparently. So the backstory was that we had two authors at the start, but our designer gave us three birds. And we followed the thread of how you build ML systems, and turned out that, yeah, it's more than engineering, it's more than just product, it's also how teams scale. So then three of us, came together, and yeah, so three authors, three birds.
Gotcha. That's cool.
and yeah, the third author who can't join us today because she's off touring around Europe is Ada Lung as well.
Ah,
And so that theme of three comes out a bit in the book. We recognize that building ML solutions and products is a multidisciplinary exercise at the moment. If it ever was the case that you could hire a team of data scientists and put them in the corner and expect to deliver a business product out of that exercise, and those days are long gone. Most organizations build ML and AI products in cross-functional teams,
mhm.
and this was a theme that we really wanted to highlight in the book. And as a result, yeah, it's got these three parts. These three themes come through again and again. We look at building the right thing, so taking that product lens. How do you easily test the market product fit before investing a lot in data collection and algorithmic tuning. Then we've got building it right. So what are the engineering practices? And here we borrow a lot from the software engineering world to tame the complexity of ML systems. And then we wrap up with a look at building it in a way that's right for people, or a humane approach. So what are the team dynamics in environments of uncertainty and diverse backgrounds working together to solve complex problems? But also, we realized through this exploration of how do we make teams effective, that there's also a lot of factors outside of teams that make them effective. So this is the wider organizational context. If you're working in a central analytics or data science team, trying to serve a huge number of organizational stakeholders across different domains, that's a pattern that's not set up for success. And so we look at team topologies as the model between teams, another layer of effectiveness so that within a particular team, you can look beyond to the wider organization and identify the factors that might make your team more or less effective that are outside of your team.
That's interesting. And you said something that I want to dive into, which is I think the earlier sentence you had mentioned when you started Dave Calls was um, hiring some data scientists putting them in a corner and having them do work. This has been, I would say, the archetypal pattern for data science teams is, especially this was prevalent during the data science boom. I would maybe call that data science boom 1.0 because I think we're sort of in the middle of 2.0. But 1.0 was the data scientists, which was the sexiest job of the 21st century.
Mhm.
I think what you saw often is you'd get there's just I think this idea that we could hire people say out of grad school, particularly if they had a STEM PhD, put them into a business sight unseen, and they would just absolutely crush it. What are your thoughts on that pattern?
Yeah, I don't think it sets anyone up for success. As you said, coming straight from grad school or a PhD environment, where you've been doing some amazing stuff with maths and code and data, but over a long time frame and with a very specific focus and a consistent focus, then get dropped into a modern technology business, expected to work in a cross-functional way on very short time frames in a very iterative manner. That's that's not a pattern that sets either party up for success, the business or the data scientists that are being brought in. When the reality is that products are built in cross-functional teams and in short cycles. And we really need to look at how we put our teams together to get the most success. I'd seen numerous organizations, back in that V1.0 data science is the sexiest job of the 21st century boom. But also, I mean, just talking to friends the other week, that there's still this pattern of functional specialization in organizations. We have a front end team and we have a pipeline team. They're both working together to deliver features to an end user, to a customer. But if we keep them separate, then we don't get that flow of work. We don't get that early feedback. And when we try and put the two parts together, they don't match up.
Yeah.
And so, yeah, talking to a friend recently, he said this was exactly his experience, that two separate teams had spent 9 months getting nowhere. His first action on joining that environment was to ensure that together those teams delivered a single feature through to the user, and that started to unlock their productivity and their flow, and really improved the working environment for everyone as well. So I think, yeah, my thoughts are that our starting point should be multidisciplinary teams for delivering these solutions, cross-functional, end-to-end, or in the team topologies model, stream-aligned teams. But given that that's the starting point, we all know that things get complex from there, especially the number of itties that teams are expected to cover these days. If we architectural cross-functional concerns, then we need to start looking at how we support that stream-aligned team that can work with minimal dependencies. We need to look at the wider organization, how other teams support them.
Got anything you want to add, David?
Yeah, I think the lived experience of working with teams who's kind of started as with functional specializations, like there's a science team and then there is an ops team. It's kind of classic DevOps divide, which, the whole DevOps comic, if you remember, this giant crashing ball breaks the wall. We come together, we get fast feedback. So I think in at least two teams that I've worked with, that was the first maneuver we did, which was the inverse Conway maneuver. You've got Conway's law, you've got two teams, the architecture and the repositories and the pipelines map and reflect that silo, and a lot of rework, a lot of handovers, long feedback cycles. So yeah, when we did that inverse Conway maneuver, brought the team together, then instead of a PR from a pull request from a scientist that takes maybe like 2 weeks to get reviewed and back and forth, kind of we get that fast feedback in a desk check within like 15 minutes or 20 minutes, you get that fast feedback. So that was a kind of quick tactic that I think many teams, is a low-hanging fruit that's kind of quick wins for the team. And I think another element that came up in our experience working with different data teams, ML teams, is the aspect of trust. So it sounds a little bit soft or waffly, but there is this immense psychological barrier when you're in two teams. We've got our agenda, our backlog, our roadmaps. But when you kind of organize the team towards the same common goal, then that trust is easier built rather than having two teams. So when there's not that trust, then a simple conversation becomes like a 2 week agenda with a pre-read, with architecture review. So it's just, I guess, thinking about for the context that people find themselves in, what are the missing feedback loops and how we give the teams and the practitioners the fast feedback they need. So that's one of the levers that we've seen work really well for ML teams.
That's really interesting. So your book is effective machine learning teams. What makes machine learning teams different than, say, a data team or a software team, or you say a front end team or a back end team or whatever? Why the distinction of machine learning teams? What makes them different?
Yeah, I think machine learning can be orders of magnitude harder than software engineering. Um, in there are some certain challenges that you don't see in software engineering, and similarly, there are software engineering challenges that we don't see, for example. Um, so from machine learning, like it's common to see like data pipeline jungle. You've got your training pipeline, but it's got upstream dependencies, and then if you draw a graph of this data lineage, it's easily complex. You've got your scale or compute requirements that you need 100 nodes or sometimes GPUs that maybe even cloud providers may not have on demand. And another symptom is that monitoring of ML system is not just whether your service is up and running, is it 4 nines? It's also like it could be spewing gibberish. And if you don't monitor that, then your customers are suffering because of that lack of monitoring. So there are a couple of, I think, unique requirements of building ML systems that we've seen time and time again. Earlier in your comment, like, can we just put a group of data scientists and go, crush the problem? We found it's no, right? There are these pathway of kind of jobs to be done in an ML system. Like you've got to have ways to test the system. You gotta have ways to refactor the system so you tame the complexity. You gotta have ways to monitor the correctness and grow the ground truth. So there are these kind of unique challenges of machine learning systems. And I think I heard somewhere, Joe, you reference yourself as a recovering data scientist. Is that right? I don't wonder
Yes.
if you have kind of what your view about, that side of yeah, ML systems, what your take on it is.
Oh, where to begin? Well, I mean, I've been doing quote data science, I think before it was officially a term, but I remember being caught up in I guess data science 1.0 bubble, being hired as a data scientist, and often finding a situation where there was little to no data upon which to do the science in quotes. And I'm sure you're nodding your heads. You've probably seen the same thing. Either the data is simply not available, or the systems to provide the data in a reliable manner, in a way where there's high data quality and so forth to be used for machine learning simply wasn't there. And so, I guess I'm the kind of guy that doesn't like to sit around and loaf and do nothing. So I started building the systems to do my job, right? And I guess that was sort of the early archetype of what became data engineering. It was more of a support function for data science. And so I'd recognized early on that, the algorithms part of data science and machine learning is certainly difficult. Especially when you're trying to maybe fit an algorithm to a data set, right? But oftentimes, I think the harder thing is the engineering involved to productionize it, and so that's where the recovering data scientist part. Right? I think I just got jaded on seeing not only myself but also my peers, and especially people who had come out of PhD programs, for example, and go into industry. And I think there's a very high expectation for what these people were capable of doing versus the reality of the job in which they entered. Complete mismatch. So I got jaded on data science, for
Yeah.
lack of a better way of putting it.
Yeah.
And it's interesting what you say that often the algorithms that data scientists are working with are open source, and there's plenty of examples out there of successful application of these algorithms.
Yeah.
Um, but the differentiator for any business is the data that they hold, their proprietary data that's unique to their business.
Oh yeah,
Um,
and not all
yeah.
algorithms are not one size fits all. I think that's one of the
Mm,
misnomers. It really comes down to how do you understand the data and how is it construct, especially when, if we're talking about tabular data, which every business has, right? That's actually really hard, and it's not
mm.
solved.
XGBoost is all you need.
XGBoost, I mean, it's great. Yeah, it's all you need. But that's the old misnomer. But it's funny because I mean, I think during the deep learning hype cycle too, when that was in full swing, there was this notion that, even XGBoost was going to go away and all you needed was deep learning,
Mm,
right? You don't even need to do feature engineering anymore. Just throw your tabular
mm.
data sets in, and you're off to the races. And I think we come to find out that's probably not exactly true. But yeah.
Yeah, yeah. Look, and I guess that's an interesting scenario we saw in our client work. The rise, there was a period, and we continue to see the rise of self-service ML or data science platforms as well.
Yeah.
They're great at sort of architecture search or hyperparameter tuning, but promise to enable citizen data science. But as you highlighted, ensuring that the data comes through in a high quality way, that we're engineering features that are predictive for automated searches. That's still a key enabler, and another reason why we need to look at a team with the capability end to
Yeah.
end to deliver those solutions.
For sure. Now, one thing that I hear often is that there's one thing I see often, I should say, on social media, which is obviously the source of truth for everything, is there's an archetype of different types of teams that you need to have. Like you need to have maybe a ratio of, X number of data scientists to X number of data engineers or ML engineers. What do you think of this ratio way of thinking?
Yeah, I think it's maybe emergent rather than a target. But you see, depending on the shape of team, and so this is some of the detail we explore in the team topologies model in effective machine learning teams. Depending on the shape of team, the role they play in the organization, you might have a different ratio. So starting from that fundamental unit of scale, which is the stream-aligned multidisciplinary team, where you've probably got product, AI, data engineering, and maybe some software engineering in equal ratios in that sort of team.
Mm,
Uh, but as the use cases get more complex, and or the ML or AI organization within a wider business gets more complex, then that sort of team isn't going to enable you to scale forever. If you continue to add more stream-aligned teams, you'll keep solving the same problems over and over again, and won't see any returns on scale. So then we see there's kind of two other patterns that you might use to scale those stream-aligned teams. And in team topologies, they're called a complicated subsystem team is the first kind of pattern. And how I describe that is it evolves around a common set of business problems, which have a common set of techniques applied to them. So yeah,
mm,
you said algorithms aren't one size fits all. In particular business domains, you're probably going to be focused on a particular set of algorithms, like regression for valuation versus natural language understanding for content moderation.
mhm.
And so that's another type of team that you might see, a complicated subsystem team or a domain machine learning team is how I've described it. And so in that team, you might see a higher ratio of data scientists and data engineers in that team because they're really focused on creating a differentiating capability for the business that multiple product teams can draw on. But at the same time, you want them to be having a product mindset, and you want them to be exposing their solutions as services so that they can scale their impact to the business. So they're not just collaborating with one or two other teams at
Mm,
any point in time. The interaction modes, I guess it's worth calling out here, is a key element of the team topologies model as well. Often we sort of focus on the team shapes, but what actually drives the team shapes giving any one team a manageable number of interactions. So you could
Hmm.
have a high bandwidth collaboration with one or maybe two teams at any time. But if you're exposing your solutions as services, then you can serve hundreds or thousands of teams in that way. The other pattern we see, so the other dimension of scaling is maybe those kind of very common technological solutions that any team could use, such as access to data, access to compute, without having a specific business application or a set of data science techniques. And so that would be the platform team. And so in a platform team, its aim is to serve many other teams as a service, as to be able to make sort of known problems, to avoid multiple streamline teams having to solve the same known problems over and over again. And
Interesting.
so that team's probably a little bit more engineering heavy, but they need software engineering heavy to be able to deliver those services. But they need some degree of domain expertise to understand their customers, internal customers as well. And then the final team shape is an enabling team, which is kind of like an internal consultancy, but some specialized area of machine learning or AI. And rather than kind of scaling known problems, they're taking novel problems that every team faces, but in maybe a different way, such as responsible AI or privacy or something like that. And they're helping each team work through solutions. And so there, you've probably got deep domain expertise in that area of enablement in that team. And so data scientists with that deep expertise, for instance. But you also need some degree of consulting capability. You need a mindset where this enabling team is working with multiple product teams to solve their problem and then move on to the next problem. And hopefully the way they solve their problem, it can be systematized into platform services over time as well.
Yeah. And to add a little bit to that point about as a service modality or as a way of scaling a team's capability, we saw a case, I call it the tale of two velocities. There was one team that was kind of feeling a bottleneck where like the data engineers and ML engineers had to bend over backwards to smuggle data from all manners of places to do like an email marketing campaign. It was like a several months program of work. And when it was done, like all of that work was like a one-time bespoke use because that data product didn't really have a API or that didn't have a way that you can call it as a service. And on the other hand, there was another team that built a similar thing, kind of a recommendations model. Like for this user, I'm going to show this set of products. They built it for one bespoke streamline team. For let's say it's an email marketing, but then it was encapsulated as a data product that the mobile team can call and the web front end team can also consume. So that team, that complicated subsystem team, once they have built that recommendations data product, that encapsulating that as such, enabled them to scale and then move on to the next fun problem to solve.
Interesting. Dave and David, you both mentioned something that I think y'all should talk about, your ex thought workers. And there's this notion, Dave, I think you said product mindset. David, you mentioned data product. These are sort of the terms du jour in the data world today. But by my reckoning, I don't think that there's an agreed upon definition or vocabulary or way of thinking about these things. How do you describe a product mindset? And I think data products, which I believe are related to each other, right?
Hmm.
How would you go about describing these to people?
Well, yeah, I think it's about first up building something that solves a problem. So thinking about a product as a solution to a problem rather than something you produce. And so that means understanding the needs of the users of that product. And so, I guess to contrast with how it might often be done in organizations, building a kind of single view of a customer. It's often a long analysis exercise that results in a one size fits none solution because every part of the organization has a different need for that view of the customer. And, they want an authoritative view. They want to understand authoritatively from the domains, what a customer looks like, and they want to be able to customize also their application of the data to their needs. But if you go through this exercise of building a customer 360 data set without understanding those different needs, then as I said, you end up with a solution that doesn't meet anyone's needs. And so that's a counterexample. That's not product thinking. Product thinking is maybe having a different view of the customer for each consumer according to their needs. So you might look at clickstream data, and your marketing team might have a very different set of needs to your security team from that clickstream data. And so first up, it's understanding the use case. Then when it comes to like delivery of this as a thing, turning it into a thing, you need to bring that thinking around not just desirability, as we talked about what the user wants, but the feasibility and viability, of building a solution that's sustainable longer term. And so that's where engineering practices come in as well. And the design of teams that rather than deliver something that gets forgotten about or no one ever uses, are actually deliberately trying to build long-lived assets rather than data inventory in the organization.
Mm. What are some anti-patterns you see right now with data products?
I think a common pitfall is building a product without a need. It's very easy to get caught up in the feasibility. Like technically, can we build this? Or, but not collaborating, I think, with product. So that's a common failure mode that we've seen, which is go along and spend $500,000 or however many months to build something because we think people want it. But yeah, even just simple kind of product thinking practices or hygiene that would have tested that assumption that people want this or this is going to help our customers. Simple testing through customer research, product discovery, that could have saved or given us that fast feedback in a week or 2 weeks of a product sprint or discovery instead of 6 months of investing everyone's time. So yeah, I think that's common failure mode. And the faster we can have that discovery in a cost-effective way and decide to pivot or persevere based on the signals we receive from customers, from business, then that will save, I think, teams a lot of time and money and morale.
I think, and I know you're a fan of lean as well, Joe. I think there's a sort of failure mode in trying to inspect quality into data products rather than address quality at the source.
Yeah.
It leads to a lot of over processing and waste in the and low quality data products that don't build trust from their consumers, and hence undermine the value. If we don't make an effort to go right back to the source and understand how we build quality in from the point of data capture.
I do have a question
Yeah.
for you because when I'm at conferences, I'll look at some of the products that vendors have, and I'm seeing data products popping up as a feature almost. Like
Mm.
I will share a database table as a data product. In your minds, is that a data product, a database table as an example?
I think obviously the functional, if I can use that word, functional data that sits within a data product is a key part of it. But there's so many cross-functional concerns you need to consider to actually make it a data product. Like it needs to, you need to have all of the governance capabilities and metadata capabilities around that data set, that functional data set, to make it a data product as well. So, with a claim like that, I'd look at what else is supported beyond being able to access a data set.
Well, if that table tells me what my customers are going to buy, then arguably it can be a data product. But there's so much upstream that needs to happen, and there's no magic that's going to create a table that tells you, what your customers are going to buy or look at next. But yeah, so the team and the effort and the resources that go into creating that thing that's going to solve a business problem, for example, telling us what our customers want, that would be a better product. But yeah, it's hard to kind of get that off the shelf without that domain expertise.
Yeah, it kind of reminds me of what happened with data mesh, where vendors were pitching data mesh uh, tools. Like,
Mm.
you just share your data, and then you have a data mesh because you're sharing and collaborating on it. Therefore, mesh. And that was, I think, around what 2021, 2022. Then ChatGPT happened, and all of a sudden, everyone just pivoted to being an AI vendor. So they quickly lost the data mesh polish on it. But yeah, interesting aside. But I guess on the notion of data products, is there a parallel notion of an ML product?
Well, yeah, I mean, if from one perspective, like an ML product is just a data product with a fairly complex transform.
Yeah.
Yeah, a learned transform. Yeah, maybe multiple stages. So, but then it also depends on this kind of boundary between the analytic and the operational world as well.
Mm,
So, yeah, I think, data products are kind of conceived mainly in the analytic world. Whereas if you're doing live inference, you don't necessarily have a sort of materialized analytic data product in the ML space. Yeah. Whereas, yeah, if you're doing batch inference, then now you have potentially another table
yeah.
of customers with propensity to do something, and it sort of sits neatly in analytics space as a data product.
Hmm.
But yeah, if you're looking to do it, yeah, live inference, then maybe you're looking at an API, a software service instead.
Got it.
I wanted to call back to an earlier point, maybe 3 points back on the lean and what Dave was mentioning about the deadly waste. So Dave has this fascinating talk. I think it's called the seven deadly wastes of data, something like that. Do you want to talk about
Yeah,
that a little
just
bit as a
seven
failure
wastes.
mode?
No
No
judgment on whether
deadly.
they're deadly or not, but they're certainly wasteful.
Yeah.
Seven. Okay, let's talk about that.
Sure, yeah, I'll try and enumerate them. So we start with overproduction. So this is building things that customers don't need, and that means that yeah, every activity you do is wasteful if you're building something a customer doesn't need. It can be hard to figure out exactly what customers need. We need to iterate and experiment to do that. But yeah, as David said, if you go ahead and build something that no one uses, that's a form of waste. Then I'd probably look at inventory. I think it's a particularly pernicious thing, and it's not well managed in the data world. Often it's incentivized by vanity metrics like the amount of data we hold.
Mm,
And the number of programs I've seen that have reported just the size of their data platforms without any connection to business value. Um, so inventory is like recognized as a lean waste, and that's data in process that hasn't reached a customer use case. So it could be something we've collected and we haven't processed. It could be something we've processed into a model internally, that no one uses. And so, yeah, in any stage of processing, but also other disciplines like accounting recognize inventory as a waste and a business risk. And so I think, yeah, we can get a lot smarter around how we recognize data inventory and how we deal with it in our organizations. Like over processing is one. So yeah, doing more work than is required. This is correcting quality downstream of the issue, attempting to correct quality downstream of the
that
issue
happens all
rather
the
than
time in
addressing the source.
analytics.
It does exactly, and yeah, I'd say that's if you look at it through a lean lens, then you say that that's over processing.
Yep.
I think a really interesting one is the waste of transportation. So
Yeah.
you'd say we're dealing with digital data. We can copy it perfectly from place to place. And lean says transportation can damage products during their manufacture and creation. Like, how do we damage digital data? I would say we damage it by losing its lineage. If we don't know where it's come from, if we can't trace it back to its source, then we lose trust in the data. Internally, it's damaged. We may not be able to satisfy compliance requirements. There's a whole range of ways that by losing that metadata through transportation, we damage the data we're working with. Um, Now there's motion, of course. In lean, this is people doing unnecessary tasks or overly complicated tasks that could be better automated. The amount of analytics that happens in Excel spreadsheets, there's a good reason for it when you're exploring what needs to happen. But at some point, we need to look at automating those valuable flows, and that's eliminating the waste of motion. Um, we have waiting as well. Waiting is like one of the big motivators for stream-aligned teams and for the team topologies model. In some research that I did years ago, we worked with a delivery group that was transitioning from waterfall to a dozen or so agile teams. And what we found was that as those teams could largely deliver end to end, but as soon as a piece of work went outside of one team and depended on another team, it would take 12 times as long as a median measure to get done.
Oh,
The median cycle time went up from 2 days to 23 days in
wow.
that scenario as soon as the piece of work went outside of a team. And so waiting, it can be invisible. Yeah, some good reading on this front is Don Reinertsen's Principles of Product Development Flow
It's a
and
good book.
making cues visible. Yeah,
Hmm.
and so the waste of waiting can be particularly huge. How am I going? Yeah, am I six or seven? I've lost
I think
track
that was
because
7.
we've
Because I'm
got
looking at
defects
because
is the
there's
final
the
one.
there's the there's well I'm looking at the 8 wastes of lean. And then I'm like wondering why did you say 7? So I'll get into
Yeah,
that.
yeah.
But
I think there's been an eighth added since
Yeah.
based on the framework that I adopted in this case.
I think the eighth was talent. Like after all of that motion and over processing and all of that toil, then we lose talent, if I recall
Mm,
correctly. Yeah.
yeah. But and what's interesting in the data space, and I think like if we talk about the history over the last decade or so, is we kind of have an operational lens of every like we have this data factory or this data supply chain. Every day we run it and it produces something. But as data engineers, and we're actually working on reconfiguring that factory to make new products in new ways and improve its processing. And so taking the lean lens, we can both look at the sort of manufacturing operations perspective of data, but we can also look at the knowledge work, software engineering exercise of redefining that, re-engineering that software-defined supply chain for data in organizations. So we can actually take, those 7 wastes and we can look at them through both the operational and the knowledge work lenses.
mhm. Makes a lot of sense. I like the way you articulated that too. That's really good. So
Well, thanks.
yeah. Well, I mean, I think it's sort of the encroachment of lean onto data and ML now. We've had, I mean, DevOps has done this for years, but then I always joke that data and ML are about 10 years behind where software's
Yeah,
been.
yes.
So, um, and DevOps, I mean, that's an extension of lean. At the end of the day, it's about continuous delivery of high quality products that people want in
Yeah.
software, right? In the days before DevOps and Agile was exactly what you described with the waterfall mentality. And it's interesting because even waterfall, if you look back at the original waterfall people, it actually people took that in a weird way too, because it's like it's command and control. But the original waterfall people are actually allowed for iteration, which I thought was
Mhm.
interesting. So, um,
And yeah, and I think it is like if you actually look at the principle of fast feedback, like in a waterfall environment, you can still find ways to get fast feedback.
oh, for sure.
That was, yeah, actually like a big part of my early career working with physical engineering industries, building
Mm,
virtual prototypes and simulation tools. So how can we shift that learning earlier in the development cycle by doing it in a virtual environment rather than in the real world?
right. Makes a lot of sense. Kind of switching gears a bit. So, y'all wrote a book. What was that process like?
Yeah, it was longer than we thought it would take, but it's good. The story I tell is like I thought we set out to write this book because we know so much from our delivery practice, from building ML systems. We want to share these ideas. And through writing, I realized, oh, there's so much I don't know. So
Mm,
it's been really great, exploring different threads, themes. We started approaching it as an engineering problem because I'm an engineer by trade. So I thought, okay, these ML systems are hard. There's pipeline jungles, there's tech debt, there's 400 line Python scripts. So if we can test these systems, then we can refactor it, then we can get fast feedback. But then as we pulled this thread a little bit more, we realized that product comes as we just discussed. Then we kind of spent 2 chapters fleshing out how we do product discovery in ML systems and the experimental and uncertain nature of ML systems. Sometimes you do have to spike things out. You do have to build a prototype instead of just kind of whiteboarding or workshops. And then as we pulled this thread a little bit more, we said, all right, we can do product well, we can do engineering well, we can have many stream aligned teams, but then we still see the problem that Dave described, where you have multiple stream aligned teams delivering stuff, but reinventing the wheel repeatedly. You see Conway's law at work. You see toil and bottlenecks. You see data not being there, platforms not being there. And then that brought us to learn that it's also a team problem. So Dave mentioned the rule of threes or the theme of threes in our book. So the as it landed, it became product engineering and teams. So yeah, through the process of writing that, I think we came to a holistic understanding of like almost like a pre-flight checklist. Like if you're gonna stand up a team or if you're gonna uh, rework a current team that's having some capacity challenges, then these are kind of pre-flight checklists that we go through, like around product engineering and your team APIs or team patterns. There's no one size fits all, and when do you use the right shape? Yeah.
Mm.
Dave, what's your experience or what's your take on the process?
Yeah, yeah. For me, like, as David said, I thought I had a lot to share. I've been as a consultant working one-on-one with people, building a shared understanding in an iterative way. Writing a book really needed to be clear on what I was trying to say to a really wide audience, and yeah, revising and revising again, and often it was leaving a lot of things out. What was the challenge? So I think, yeah, knowing when to stop, and each chapter in our book could potentially be another book in its own right, and
Hmm.
especially when we focus a lot on the engineering practices to maintain to tame that complexity through the core of the book. But if we look at the product introduction at the start, we reference a lot of different techniques in there. We look at the team dynamics section. We reference multiple entire books in that section. So it was really a question of where to stop and how to package something that someone we'd never met could pick up and make effective use of in their daily work was the big challenge.
You
But the
just
really
showed us.
rewarding thing for me was that, the emergent things that came out of it. So, that chapter on team topologies, the final chapter, number 11, around, again, the levels of three. We look at individual effectiveness, we look at effectiveness within teams, and we look at effectiveness between teams. That chapter wasn't in the original plan, and it was really
Interesting.
great to just see it emerge from the process of trying to share the original plan with an audience.
That's cool. Shout out to Radiohead for the quote there. That's cool. Um, that's interesting. I'll have to give this a look. By the way, did you guys put the quiz questions in here?
Yeah, that's a new feature on the O'Reilly platform to, I think,
Oh,
to active recall and
oh, interesting.
improve learning.
I'll have
So
to see
yeah.
if that's on my book. That's interesting. Yeah, I like the flow of this, right? Where always are the challenges, and then you kind of get into descriptions of things. Then the final chapter is always a hard one. I feel like because it's like you kind of you're coming back to the punchline, right? And
Mm.
um, it's always one of those things. I don't know about you. I'd love your thoughts on this. But the final chapter is always feels like you're writing it in the back of your head, probably every day as
Mm.
you're writing a book.
Mm.
You're just walking around like you're sort of processing it. I mean, walk me through this. What you said that the final chapter wasn't supposed to be there when you started. Like, how much of what you thought you were going to write did you end up writing? versus how much did you end up changing?
Mm.
Yeah, I
Like,
think
yeah, so yeah, you go, David.
yeah, I think one of our mentors when we started writing the book was Neil Ford, who wrote
Oh, he's
Evolutionary
good.
Architecture. Yeah. So one of the ideas he shared with us is that you may follow a thread or have a plan to do something, but as you write, the story or the narrative will lead you somewhere, and be comfortable with that flow. Go with that. And so for us, that was we started to think ML. Yes, you need engineering, you need ML, you need data, as we described in your recovering data scientist journey. But as we followed that, we found that actually data was very well written about. That's your book, obviously, Joe, and many other
Like thousands of others.
aspects.
Yeah.
Yeah, exactly. Building data intensive applications and things like that. And so we decided, that's already written well about what's our literature going to contribute to. And teams was that aspect that emerged, as Dave mentioned, the emergent aspect. Like we see teams on the ground building these streamlined products, doing these engineering best practice, but still there was that team aspect of do you have the right team shapes, or are you having handovers and waiting between two teams? And another interesting one was scaling ML across an enterprise or an org. So there are a
Mm.
couple of scaling modes, right? You throw people at the problem, just hire lots of ML engineers, data scientists, put them in different streamlined pods, do different things. Um, or you can centralize totally. And the lived experience of that was that that team feels like a bottleneck. They can't service every need in the organization. So then we kind of explore what are the patterns that we've seen work, like slicing by domain, what Dave mentioned about complicated subsystem teams. Um, so yeah, I think Teams was an emergent property that was in the reality of how practitioners do ML that wasn't there at the start, but we're really happy we landed there.
That's cool.
Yeah, and yeah, as you said, it's good to start with the challenges, and we had a kind of protagonist and who was working through the challenges of working in ML in complex environments, and now as we kind of ticked off each of those things to address, got up to the team dynamics section, and you asked, what did I leave out? I thought I'd have a lot more dimensions to talk about, but in the end, I boiled it down into kind of trust. But within trust, uh, people working in team environments having an understanding of the research and the models that we use for teamwork currently, and to be able to put themselves in someone else's shoes. And so there are referenced a bunch of kind of standard things like Tuckman's stages of group development, like Belbin's team
Mm.
roles. I'm a resource integrator, so that's why I keep bringing newer information into the work that I do at any point in time from a Belbin team role perspective. And so a whole range of models like that, so that individuals in a team have a framework to understand their relationship to the rest of the team. So trust was one, then communication, how we talk, building on trust, how we talk to one another through different channels in, very complex distributed environments that we tend to exist in currently. And then I had to look at progress, like meaningful small progress, the power of small wins, and the role that teammates can play as catalysts in that as a really important driver for team dynamics in digital product development, ML product development, and diversity. We talk about cross-functional teams. We need to bring those diverse perspectives and diverse experience and diverse backgrounds at multiple levels into teams. And so then that meant the team dynamics chapter was, had fewer focuses than I'd initially anticipated. But as I kept thinking about our protagonist and the problems that they were facing, and the engineering solutions we proposed, and the team dynamics frameworks we proposed, that Radiohead lyric was echoing through my head. I've given all I can, all of these things within my locus of control in the team, and it's still not enough because I know that there are factors outside of the team that are affecting our effectiveness. And so that was where the final chapter came from. Like we need a framework to look at what's happening outside of the team as well, so that you could either from the within team perspective, you could look out and say, well, that's the environment I'm seeing, and this is an issue that we need to resolve. Or as a senior leader in an organization, looking down across multiple teams, you can identify the anti-patterns or the areas for improvement.
Oh, that's a big one too, because it's all these outside forces that impact your team that I think
Mm.
people feel it's sort of like the gravity of dark matter, for example. You can't see it, but it's omnipresent and
Yeah.
you can ignore it at your own peril, I suppose. But it is a huge force. It's the force that I think operates throughout all departments and companies, right? And it's sort of this
Mm.
Conway's law sort of hints at this back in his old paper about like subcommittees, and I think all this work was fascinating. Read it was like he had all the graphs and nodes and stuff, which is quite ahead of its time. Um, but it's that whole notion is interesting because I think it's something where I think we people ignore it because it's like we're even if you're quote delivering data products, whatever, like it's easy to ignore the external concerns in the company. But I notice when I talk to leaders of, say, heads of data, for example, or heads of technology, I mean, a lot of their time is spent interacting and aligning with other leaders who are probably
Mm.
equally confused about the dynamics of how all these teams are supposed to operate, right? So, yeah,
And yeah, that like these value flows often cut across different leaders' areas of responsibility
they always
too.
do.
Yeah, yeah.
Yeah.
So that's an extra challenge for those in those positions to manage within their domain, but also in a way that across domains line them up to uh, deliver value to the business's customers.
Well, data is particularly interesting because it cuts across so many different uh, organizations and departments where
And
it's
yeah,
not a clean thing.
exactly.
Like, oh, well, we're even if you say we're the I have a chief data officer now, and we're the data organization. It's like that's cool, except all these other departments before you came in also had data, and now
Yes.
it can become very territorial. So it's
Comes back to the data mesh conversation, I guess there
mm,
around yeah, and yeah, precisely often data's collected in one domain and used in another domain within the business. So yeah, by its nature, it cuts across.
yeah. And not just business internally, but also externally, right? Increasingly, it's about information flows between organizations and companies and governments and so forth. So it's just, I kind of look at it like a continuous stream, sort of like the water cycle is more of what I'm starting to equate it to, where it mutates. It doesn't really ever go away. Um,
Yeah, yeah.
just
And
changes
yeah,
form.
as businesses become more interconnected, there's more motivation for that data sharing in one model or another.
Yeah. Are you guys going to write another book?
I mean, I like the idea of expanding on this effective teams angle, but broadening beyond machine learning as well, and how work works in data organizations with a lean perspective as well.
Hmm. That'd be a great one.
Mm.
Hmm. That's cool. Are you guys going to take some time off or are you guys going to jump into it?
We're just coming into summer holidays here in Australia, so I am planning to hit the road this afternoon, bushfires permitting, as we just
Oh,
had a
you
run
have
of hot
those right
weather.
now.
Yes,
Oh.
yeah.
Interesting. Let me
So
Google that real quick. Bushfires and
yeah.
I guess you call them bushfires. We call them forest fires here. Let's see here. Bushfires in Australia. Um,
Yeah, it was like 42 degrees on Monday, 2 days ago. And yeah, there was a total fire ban as well.
looks like you have them. Yep.
Mm.
Yeah,
Interesting. Well, Melbourne is it seems like it's a lush area, but I was reading there was actually droughts there years ago. Is that true or
Yeah, going back about nearly 20 years now, we had some quite severe droughts. Um, it's interesting. It's got a reputation. Melbourne, it has a reputation for experiencing four seasons in one day.
oh, I've
They
seen it.
say, yeah, they say if you don't like the weather, wait 5 minutes. And it sits between the desert and Antarctica, basically, is the reason for it. And so it has a reputation of being cold and drizzly as well, but it actually receives less rainfall than a lot of other Australian capital cities who have
Mm,
more of a Mediterranean or a tropical climate. So we are at risk of drought, and Australia in general is a very dry country.
yeah.
So we have to be careful how we manage water.
Yeah, it looks like it. I mean, I remember flying over on my way to Perth. And I was like, holy cow, this place is like Mars.
Yeah,
Like,
yes.
like uninhabitable. I mean, yeah, it's crazy. Well, cool. I hope we have a good summer trip then. It's winter here. I was literally just looking at snow up in the mountains here, so um, it's funny how the seasons are completely different. But yeah. And in Melbourne, by the way, coffee for the audience. Melbourne touts itself as having the best coffee on the planet. Can you guys talk about that for a second?
Yes, no argument. Yeah,
Leave
it's been a journey. Like it hasn't. It's been interesting to see how all the elements come together. So we've got a big migrant population in Melbourne from post-war Europe, and so that drove a kind of a cafe scene. And then probably 20, 25 years ago, Melbourne City started investing in the kind of laneway culture that we see. So,
Mm.
lots of bars and cafes down at the end of a bluestone alley behind three sets of rubbish bins, serving amazing produce.
Oh, it's killer. I mean, I remember when I first I've been going to Australia now for a few years. Shout out to Peter Hansons, by the way, for Data Eng Bytes, the whole crew there. But yeah, I think when people would say hi, they wouldn't even introduce themselves. They would just say, "Have you tried the coffee?" And I'm like, but after seeing this about 20 times in a row, I was like, okay, I got to go try the coffee, I guess. Thought that was pretty interesting. But yeah, it's legit. I'd say it's good. So congratulations. So anyways,
Yes,
yeah.
happy to give anyone a tour around if they're in this part of the world.
Yeah, it's great. Well, awesome, guys. It was great talking with you. Congrats on the book, by the way. I know it's a big milestone to have it published, and it looks like it came out pretty recently. So the audience, go buy it. It's awesome. So
That's
Yeah,
great. Thank you
thanks,
so
John, and
much,
thanks for
Joe.
having us.
yeah, anytime, guys. Cool. Well, yeah, have a good one.
All right,
Yeah, thanks so
bye
much,
for now.
Joe.
Yeah, take care. Bye.